Hello, you're welcome to this session at Medical Sciences Made Easy by Naphtali Muhumuza. In the series, how we are looking at different anticoagulants. In the previous video, we have looked at different hematological anticoagulants used to preserve blood. And we ended by looking at even qualities of the good anticoagulant, which we said that, but before that, we always remind you to subscribe. If you haven't subscribed, always hit the subscription button, like the video, and always share your comments for continuation of learning. As we said about the good qualities of an anticoagulant, we said it should be able to preserve the morphology of cells in the blood. It should prevent shrinkage of cells. And this anticoagulant should prevent clotting of the blood. So meaning whenever we use it, should be able to prevent clotting of blood. So we are saying qualities before we begin EDTA preparation, that the qualities of a good anticoagulant should preserve morphology of cells. That is, should prevent shrinkage, then should be able to prevent clotting, blood from clotting, and should also prevent hemolysis. Should not cause hemolysis to the blood. So a good anticoagulant should not cause hemolysis to the cells, and they should be soluble so that they do not cause hemolysis. So these are some of the qualities of a good anticoagulant we are seeing today. And in this session, we want to discuss majorly on how to prepare an EDTA tube to preserve a certain amount of blood. This is very important to know as a lab student, to always know how to prepare these tubes. Even you can make it as a company. You start producing these tubes for our own laboratory without us going to buy. But after seeing these qualities, now we need to look at EDTA as a standalone. And this EDTA tubes so they come in the concentration, they are majorly come in salts in the concentration of either 7.5 grams, or we can say percent. They normally come in percent as sodium as 7.5% or 10% EDTA salt. And this 7.5% or 10% EDTA salt, this 10% I can even ask you, I can also bring it in 10 grams per deciliter, and this is also the same as 7.5 grams per deciliter. So whenever I ask you a question and I say, given 7.5% EDTA salt or given 7.5 grams per deciliter, a deciliter means per 100 mils. This one, deciliter means per 100 mils. So don't always be confused whenever we bring for you to prepare an EDTA tube using 7.5 grams per deciliter. Many students know it is brought as 7.5% EDTA or 10% EDTA. But you should also know we can also bring it as 10 grams per deciliter, meaning we are dissolving 10 grams per deciliter, means we are dissolving 10 grams of EDTA salt in 100 mils, because I told you a deciliter means 100 mils of distilled water. If it is 7.5 grams per deciliter, it means 7.5 grams of EDTA dissolved in 100 mils of distilled water. So whenever you are brought that you provided a 7.5 grams per deciliter or provided 7.5%, all of them means grams in 100 mils. So after knowing this, we can easily have a question whereby you can be asked a question that describe how to prepare an EDTA tube to hold 2 mils. We like the word to preserve. To preserve 2 mils of blood given a 7.5% EDTA salt. And this one we can even give it 20 marks. So if you are given such a question, this 7.5%, even I can say 7.5 grams per deciliter. All these mean the same. So either I can say given 7.5 grams per deciliter or given 7.5%. And whenever you are given this, you start by telling us what this means, whereby 7.5% means 7.5 grams of EDTA salt dissolved in 100 mils of distilled water. So after knowing this, that we are dissolving 7.5 grams of EDTA salt in 100 mils of D water, so if 100 mils of distilled water dissolves 7.5 grams of EDTA salt, we need to know how many can be dissolved by 1 mil of distilled water. So if 100, then what about 1 mil of distilled water? Will dissolve or can dissolve, we cross multiply, whereby we are going to multiply this with this, then divided by this. So it will be 1 mil times, we are cross multiplying, and always maintain units whenever you are doing this calculation, and these mils will go with the mils. But before we go to this step, sometimes we prefer to first convert grams to milligrams. So I can even remove this, or I can even do it from here. But let me go chronologically, whereby let us first convert it. So the next step is to convert 7.5 grams to milligrams. Why are we converting? The standard is 1.5 milligrams to preserve 1 mil of blood. So because it is in milligrams, that's why we are forced to convert this gram to milligrams. And we know the truth is that 1 gram is equivalent to 1,000 milligrams. So what about, if this is in 1,000, what about 7.5 grams? It will be equivalent to 7.5 grams, you cross multiply, times 1,000 milligrams divided by 1 gram. This gram goes with this gram, and we are able to form 7,500 milligrams of EDTA. Don't leave it open, of EDTA. So these ones are the milligrams. So we are converting first. The first step is you tell us what this means. The second step, you convert to milligrams because the standard is also in milligrams. And after that, the third step is if this one is dissolved in 100, dissolves this. So what about 1 mil? Because now we are seeing 7,500 are being dissolved in 100 mils. So we are saying if 100 mils of distilled water dissolves 7,500 milligrams of EDTA. What about 1 ml of distilled water? It will dissolve. We cross multiply this with this, divide by this, which is 7,500 milligrams times 1 ml, maintain units, divided by 100 mils. Mils goes with mil, and these two zeros goes with this to form 75 milligrams of EDTA salt. So this is what is contained in 1 ml. That 1 ml of distilled water dissolves 75 milligrams. So after knowing the ones in 1 ml, and we know the truth that here we say, but 1.5 milligrams of EDTA preserves, this is the standard, preserves 1 ml of blood. That is what we know, it's the standard. It can preserve 1 ml of blood. But we have seen that 1 ml of distilled water is dissolving 75. So if 75 milligrams of EDTA, these ones, are dissolved in 1 ml of distilled water to form the EDTA solution, what about 1.5 milligrams, which is the standard of EDTA? How can we use it to make the EDTA solution? So this one will be dissolved, then we cross multiply, whereby it will be 1.5 milligrams times 1 ml divided by 75 milligrams. And this one will give us, if you can compute it on a calculator, you will find this one will give you 0.02 mils, whereby milligram goes with the milligram. Mils, these ones will be mils of EDTA solution. These are mils of EDTA solution, which can preserve, this EDTA solution can preserve 1 ml of blood. So we are saying that this one preserves 1 ml of blood. So this solution we have formed, EDTA solution, is able to preserve 1 ml of blood. So if 1 ml of blood, is preserved by 0.02 mils of EDTA solution, what about, the question is asking us to hold how many? 2 mils. So if 1 ml of blood is preserved by 0.02 mils of EDTA solution, then what about 2 mils, which we have been given? What about 2 mils of blood will be preserved by, you cross multiply, which is 2 mils times 0.02 mils divided by 1 mil, and here you are able to get 0.04 mils of EDTA solution. So these ones, and after getting this, so this, whenever we are going to prepare this tube, we are going to pipette 0.04 mils. And some students prefer putting it in microliters. They prefer putting it in microliters, whereby the 0. There is like converting 0.04 mils to microliters, which is, and we know that 1 mil contains 1,000 microliters. What about 0.04 mils? 0.4 mils will be equivalent to 0.04 times 1,000 over 1, which is equal to 40 microliters. So this is 40 microliters of EDTA solution to preserve 2 mils of blood. So, and the question is saying describe. Do not stop here. Do not stop here. This is just a calculation. So if it is taking 10 marks, you already have 5. Another 5 is for the description. So after knowing that we need to pipette 40 mils of dewater of EDTA solution, now we have to describe the procedure. So the procedure is that we are going to pipette, we are going to obtain our clean vagina, and we pipette 40 microliters of EDTA solution into a clean, dry vagina. And after pipetting those 40 microliters, we intubate at 37 degrees centigrade to evaporate the water. Evaporate the water, the distilled water in the solution. And after it has evaporated, we stopper or we cover the tube, stopper the tube with the purple top. And after that, we label. And how do we label? Don't say label. You have to tell us what you're labeling. And on the labeling, tell us that we label with the concentration of the EDTA salt, that is 7.5. You tell us the date of manufacturing, the date of preparation. You tell us the initials of the preparer, initials of the person who has prepared. You tell us instruction is to preserve 2 mils. You show us is to preserve 2 mils of blood. And you will also tell us the expiry date, and sometimes the storage conditions. So all these ones must be clearly stated in order to get all the marks. So as a students have many times the mistake of saying that label and they finish. There you have lost like 3 marks. So you have to go ahead and tell us what are you labeling on this tube. So we have seen you label with the concentration of the EDTA, the date of preparation, initials of the person, then how many mils it is going to hold, and the expiry date plus the storage conditions. And we are able, or we are good to go. So this is how we can prepare our EDTA tube, both for examination purposes and even us in the laboratory, or the laboratory personnel can venture this into a business where their role is to produce EDTA and hospitals can always buy them. So this is the example I can give you in this session, whereby we were to prepare the vagina or an EDTA tube to hold 2 mils. And we have seen steps. You begin by telling us what. So if it was 10 grams, we would have said 10 grams dissolved in 100 mils. Then we would convert 10 grams to milligrams. So it depends on which concentration of EDTA they have given you. If they give you 7.5, use 7.5. If they give you 10, then you use 10. So I can give you an assignment which you can always inbox me. No, you can send your comment in the comment section by answering this question I'm giving you. And this assignment, I want you to describe. So this is the homework. Describe how to prepare EDTA tube to hold or to preserve 5 mils of blood given 10 grams per deciliter EDTA salt. So this is the question I'm giving you to try out, and after trying out, we shall expect the answers whenever you inbox me the answer. The answer you need is the final concentration of the salt that we shall pipette to prepare our EDTA tube. And as we conclude this, we also, as the part of preservation of blood, what we need to know is in case the blood is not preserved by these anticoagulants, so what are the morphological changes that occur on blood and preserve the blood? So we can look at those morphological changes. We can look at the morphological changes that occur on blood when left to stand for long at room temperature and preserved. So we are looking at morphological changes that occur on unpreserved blood when left to stand at room temperature for long. Morphological changes. And among the morphological changes, on the neutrophils we shall see some changes, like on red cells we see crenation of cells. The cells, especially the red cells, become crenated. This one major affects the RBCs. And sometimes also the RBCs become spherical, they become spherical. So there is sphere formation, or what we call spherocytes. Spherocytes are formed, that is still on RBCs when left to stand more than 6 hours at room temperature and preserved. And what happens also, we shall also see disintegration of nucleus, disintegration of nucleus, especially the neutrophils, whereby the neutrophil become pycnotic. That if I have a neutrophil here, if this is a neutrophil, instead of its lobes being attached together, you find a neutrophil, they have split apart without a ring attaching them. That is what we call pycnotic, or disintegration of the nucleus when stayed at room temperature. Then we shall also see loss of the outlines, the margins, loss of margins of the cells. So the margins become ragged, they become ragged or irregular in shape. You find they are ragged. They are no longer round but ragged. That is what we are calling loss of the margins. That is when you leave it to stand for so long. Then we also see development of vacuoles. Development of vacuoles, especially in monocytes. You find in the kidney-shaped nucleus, the vacuoles start to develop. That whenever you have a monocyte like this, and this is the kidney-shaped nucleus, you find the vacuoles developing within the nucleus. That is what we call vacuolation of the nucleus. So these are some of the morphological changes that can occur on unpreserved blood when left to stand for long at room temperature. And the neutrophils, they can also develop what we call development of lobules in the cytoplasm. So these are the major morphological changes. We are looking at the morphological changes: crenation, spherocyte formation, disintegration of the nucleus, loss of the margin, development of vacuole. These are the ones you can see with your eyes when you are examining a thin film. So thank you so much for always being with us. Hope you have learned how to prepare an EDTA tube, and we have gone extra mile to look at morphological changes that occur on unpreserved blood when left to stand for long. Always remember to subscribe if you haven't, like the video if you have learned, and share your comments. Please don't forget our homework, and I will need to see your answers under the comment section. Thank you so much.